Hello and welcome to Nighttime Science. Close your eyes, let your shoulders drop, let your jaw unclench, unfurrow your brow. We are going to take a very long, very slow journey backward. We are going to travel back through the noise of the present day, past the bustle of the last century, past the quiet fields of early agriculture, past the ice ages and the drifting continents, all the way back to the beginning. There is no need to rush. We have 4.5 billion years to cover, and we will move through them with the slowness of a tectonic plate. We will move with the patience of a stone. Tonight, there are no deadlines. There are no urgent notifications. There is only the deep, heavy, comforting weight of time. Imagine the Earth not as it is now, but as a silent, floating object in the dark velvet of space. It is a story of slow cooling, a story of settling dust, a story of water pooling in low places and staying there for millions of years. It is the most soothing story of all because it has already happened. It is finished. It is solid. It is the ground beneath your bed and the foundation of the house you sleep in. Let us drift back to the very start, before there was blue sky, before there was green grass, before there was the sound of a bird or the rustle of wind in the trees. Let us go back to the silence of the Hadean Eon. Section 1. The Cosmic Coalescing and the Hadean Night 4,000, 540 million years ago. It is a number so large it feels like a soft blanket wrapping around the mind and quieting it. 4,540,000,000. In the beginning, there was only dust, a vast silent cloud of gas and mineral grains floating in the cold emptiness of the solar nebula. There was no sound here, just the silent drift of particles. Tiny specks of iron, tiny specks of silicate, tiny crystals of ice. Slowly, very slowly, they began to find one another. Gravity is a gentle, patient force. It pulls things together without effort. It does not grab, it beckons. One grain of dust touched another and they clung together in the darkness. Then another and another. Over millions of years, these small clumps grew into pebbles. The pebbles grew into boulders. The boulders grew into mountains floating in the void. They collided with a soft, dull thud, merging into larger and larger bodies. There was no rush. The solar system was forming in a slow, rhythmic dance of accretion. As these rocks gathered together, they grew heavy. Their gravity increased. They pulled in more dust, more rock, more silence from the surrounding dark. As the Earth formed, it grew hot. Not from fire, but from the pressure of all that rock squeezing together, and from the friction of rocks falling onto its surface. The heat grew and grew until the rock itself began to melt. Imagine a world that is entirely liquid. A global ocean, not of water, but of molten magma. It glowed with a deep, dull red light, like the embers of a dying fire in a dark room. The surface was soft and viscous. If you were to drop a stone into it, it would not splash. It would slowly sink, melting as it went, becoming part of the whole. There was no atmosphere yet to scatter the light. The sky above this glowing red ocean was pitch black. Even during the day, the sky was a star-filled void. The sun was there, but it was different then. It was a faint young sun, shining with only 70% of the brightness it has today. It hung in the black sky like a small, pale coin. In this early darkness, something monumental happened. It happened in slow motion. A planet-sized object, which scientists call Theia, drifted toward the Earth. It was not a violent crash like a car accident. It was a cosmic merging. The two bodies met, and the material from their outer layers was cast out into the orbit around the Earth. For a long time, the Earth had a ring, like Saturn. A ring of hot, glowing rock circling the equator. It was a halo of debris spinning silently in the vacuum. Over time, gravity did its work again. The debris in the ring began to clump together. It gathered itself up piece by piece until it formed a sphere. This was the moon. But it was not the small white disk we see today. It was enormous. 4 billion years ago, the moon was much, much closer to the Earth. Today, the moon is 238,000 miles away. Back then, it was perhaps only 15,000 miles away. If you stood on the cooling skin of the ancient Earth, the moon would have dominated the sky. It would have appeared 14 times larger than it does tonight. A giant glowing cratered ball hanging just above the horizon. Because it was so close, it moved fast. It orbited the Earth not in 28 days, but in just a few days. The Earth itself was spinning faster too. A day lasted only 6 hours. The sun rose and set in a dizzying rhythm. But there was no one there to see it. There was only the red light of the magma, the black sky, and the giant looming face of the moon. Because the moon was so close, its gravity tugged on the Earth with immense power. The tides in the magma ocean were colossal. Imagine a wave of molten rock thousands of feet high, slowly rising and falling as the moon passed overhead. The ground itself was breathing, up and down, a slow rhythmic heaving of the planet's surface. It is a hypnotic image. The red Earth breathing, the giant moon watching, the silence of the vacuum. Section 2, the Archean rains and the orange skies. Time passed, millions of years drifting by like clouds. The bombardment of rocks from space began to slow down. The Earth began to cool. This is the most relaxing phase of a planet's life, the cooling. Heat radiating out into the cold vacuum of space. The red glow of the magma began to dim. It turned from bright orange to dull crimson, then to gray, and finally to black. A crust was forming, a thin, brittle skin of dark basalt rock floating on the mantle below. It was like the skin that forms on hot milk as it cools, fragile and shifting. It broke and reformed. The atmosphere was thickening. Volcanoes spewed out gases from the interior of the Earth. Steam, carbon dioxide, nitrogen, methane, ammonia. The air was heavy and thick. The atmospheric pressure was immense, perhaps 27 times heavier than the air we breathe today. If you were there, the air would feel like a heavy blanket pressing against you, holding you down, keeping you still. For millions of years, the water remained in the sky. It was too hot for liquid water to exist on the ground. The entire ocean was suspended in the atmosphere as a thick, dense layer of steam and clouds. The planet was wrapped in a white veil of water vapor, hiding the surface from the sun. But the cooling continued. The temperature of the rocks dropped. 500 degrees, 400 degrees, 300 degrees. And then, the most soothing event in the history of our planet occurred. The temperature dropped below the boiling point of water. It began to rain. This was not a brief afternoon shower. This was the great rains. It started with a single drop, warm and heavy, falling from the high, steam-filled clouds. It hit the dark, hot rock with a hiss. Then another drop, then 1,000, then 1,000,000,000. It rained for centuries. Some scientists believe it rained continuously for thousands of years without stopping. The sky opened up and released all the water it had been holding. The rain washed over the jagged black rocks. It trickled down the sides of the first volcanoes. It pooled in the hollows and craters left by asteroids. Listen to the sound of that rain, a steady, endless drumming on bare rock. There were no trees to break the fall of the water, no grass to absorb the sound, just the sound of water hitting stone echoing across a dark, empty world. The water was hot, perhaps nearly boiling, but it was liquid. It filled the lowlands. It connected the small pools into lakes. The lakes overflowed into seas. The seas merged into a global ocean. This was the birth of the hydrosphere. The cool, early Earth. By 4,400,000,000 years ago, the Earth was a water world. These first oceans were not blue. They were likely green or dark brown. The water was rich in dissolved iron and other metals washed from the fresh volcanic rocks. Under the thick, cloudy atmosphere, the ocean surface would have looked like a sheet of dark oil heaving slowly with the tides. And the tides were still massive. The moon was still close. The water would rush inland for hundreds of miles, then recede, scrubbing the land twice a day. The sound of the waves would have been deafening, a constant roar of water against the silent continent-free crust. But above the waves, the sky was beginning to change. The steam had condensed. The clouds thinned slightly. The atmosphere was still mostly carbon dioxide and nitrogen. There was no oxygen. If you took a breath, you would find nothing to sustain you. But the pressure was stabilizing. We drift forward now, deeper into the Archean eon. The name comes from the Greek word for beginning. We are now between 4 billion and 2.5 billion years ago. The Earth had settled down. The heavy bombardment of asteroids had ceased. The crust had thickened. The first small continents, called cratons, began to form. They were small islands of granite floating in the vast, dark sea. Let us look at the sky of the Archean Earth. It was not blue. The composition of the atmosphere was different. It was rich in methane, a gas produced by the very first simple microscopic life forms and by volcanic activity. Methane reacts with sunlight to form a hydrocarbon haze. If you stood on one of those lonely granite islands and looked up, you would see a sky that was a pale, hazy orange, a pinkish-orange dome stretching from horizon to horizon. It was like a permanent sunset. The light from the sun was filtered through this haze, casting a soft, diffuse glow over the water. There were no hard shadows. Everything was bathed in this gentle amber light. The oceans, too, were different. We often think of the ocean as blue, but that is because of the way clear water scatters sunlight. In the Archean, the water was filled with dissolved iron. Iron is reactive. It creates rust. But in the absence of oxygen, the iron stayed dissolved, giving the water a bottle green tint. However, there is a sleepy hypothesis known as the Purple Earth. Some scientists believe that the very first life forms, tiny single-celled microbes called archaea, did not use chlorophyll to harvest sunlight. Chlorophyll is green. Instead, they used a molecule called retinal. Retinal absorbs green light and reflects red and blue light. If these microbes were abundant in the early oceans, floating in the top layer of the water to catch the dim sunlight, the oceans would have appeared purple, a vast violet sea under a pale orange sky. Imagine the color palette of this ancient world. No green trees, no white clouds, just orange mist above, purple water below, and black volcanic rock in between. And it was quiet. There was no wind in the trees because there were no trees. There were no insect noises, no bird song. The only sounds were the physical sounds of the planet. The wind whistling over the bare rocks, the crash of the waves, the rumble of a distant volcano, the sound of the earth spinning in the dark. Life was present, but it was silent. It was hiding in the shallow waters. This is the era of the stromatolites. If you waded into the shallow, warm waters near the shore of a volcanic island, you would see them. They looked like rocks, mound-shaped, lumpy structures rising out of the sand. Some were small, the size of a cabbage. Others were large, rocky domes. These were not rocks, though. They were built by colonies of microscopic bacteria. Layer by layer, year by year, century by century. A thin film of sticky bacteria would trap a layer of sand. Then the bacteria would grow up through the sand to reach the light again. Then they would trap another layer of sand. 1 millimeter of growth might take a year. To build a stromatolite 3 feet high took thousands of years. It was the slowest construction project in history. These microbial mats covered the seafloor in the shallows. They had a texture that geologists call elephant skin, a wrinkled, leathery surface. They were slimy to the touch. If you ran your hand over them, you would feel the slick biological film. These mats were the only living things on Earth for over 1 billion years. 1 billion years of silence. 1 billion years of slime growing on rocks. There was a rhythm to their life. During the day, under the orange sun, they absorbed light. During the night, under the giant moon, they rested. Day and night, day and night. The Earth slowed its spin very, very gradually. The days stretched from 6 hours to 10 hours, then to 12. The moon drifted away, inch by inch, year by year. As it moved further away, it looked smaller in the sky. The tides became gentler. The raging waves that once swept across continents settled down into the rhythmic lapping we know today. Section 3. The great rusting and the boring billion deep within the Archean, something new began to happen. A new kind of microbe evolved, a tiny blue-green bacterium, cyanobacteria. They had a special trick, a new way of capturing energy. They took water and sunlight and carbon dioxide and they turned it into food. But unlike the purple microbes, these blue-green ones released a waste product, a gas, oxygen. For the first time, oxygen was being released into the water, but it did not go into the air. Not yet. The ocean was full of dissolved iron. As soon as a molecule of oxygen was released by a bacterium, it met an atom of iron. They reacted instantly. The iron rusted. It turned into a solid particle of rust, iron oxide, and sank to the bottom of the ocean. This happened for millions of years. The bacteria breathed out oxygen. The ocean absorbed it. The rust rained down on the seafloor in microscopic particles. It settled in layers. A layer of red rust, then a layer of gray silica, then a layer of red rust. These layers became the banded iron formations. We can see them today in cliffs in Australia and Michigan. Beautiful stripes of red and gray rock. They are the fossilized breath of the Archean world. They are the record of a planet slowly, painfully trying to breathe. This process was silent and invisible. If you looked at the ocean, you would not see the oxygen. You would only see the water turning from green to clear as the iron was stripped out of it. The rust piled up on the bottom of the sea, creating the iron ore that we use today to build our cars and our skyscrapers. Every steel beam in every building in the world is made of iron that was rusted out of the ocean 2.5 billion years ago by invisible bacteria. This period was long. It is hard to comprehend how long. The Archean eon lasted for 1.5 billion years. That is 1,500 million years. That is 3 times longer than the entire time dinosaurs existed. It is vast. And for almost all of that time, nothing changed. The sun rose, the sun set, the slime grew, the iron rusted. It is a time of incredible stability, a time of low energy. The planet was like a sleeper breathing deeply in a dreamless sleep. We are crossing a boundary now. We are leaving the Archean and entering the Proterozoic eon. The time is 2.5 billion years ago. The iron in the oceans finally ran out. The bacteria had rusted it all. There was no more dissolved iron left to catch the oxygen. So the oxygen began to bubble up. It left the water and entered the air. This was the great oxidation event. It sounds dramatic, but it was a slow chemical shift. The oxygen rose into the orange, methane-rich sky. Methane is a greenhouse gas. It traps heat. But when oxygen meets methane, it destroys it. It turns it into carbon dioxide and water. As the oxygen ate the methane, the orange haze cleared. The sky turned blue for the first time. The protective blanket of greenhouse gas was stripped away. And the earth got cold. very cold. This was the Huronian glaciation, the first ice age. The temperatures plummeted. Ice sheets formed at the poles and spread toward the equator. The warm, purple-orange world was replaced by a cold, blue and white world. But eventually the volcanoes pumped enough carbon dioxide back into the atmosphere to warm things up again. The ice melted, the Earth settled into a new state, and then it entered the boring billion. This is a real term used by geologists, the boring billion. It refers to the period between 1,800 million years ago and 800 million years ago. Why was it boring? Because almost nothing happened. For 1 billion years, the Earth was perfectly, beautifully stable. The climate did not change. The atmosphere did not change. The tectonic plates slowed down. There were no major ice ages. There were no major explosions of life. The continents had drifted together to form a supercontinent called Nuna, or Columbia, and then later another called Rodinia. But even the drifting was slow. The mountains stopped growing. Erosion wore them down to flat, low plains. The Earth was smooth. The oceans during the boring billion were strange. Scientists call this the Canfield Ocean. The surface water had some oxygen where the cyanobacteria lived. But the deep water was anoxic. It had no oxygen. Instead, it was filled with sulfur, hydrogen sulfide, the stuff that smells like rotten eggs. The deep oceans were toxic and sulfidic. If you could dive down into the deep ocean of the boring billion, it would be dark and it would smell of sulfur. But the most striking thing about the Canfield Ocean was the color. The sulfur-loving bacteria that lived in the middle depths were purple sulfur bacteria. They formed a layer, a plate of purple biomass floating in the water column. Some scientists think the oceans of the boring billion were not blue but a milky turquoise color, or perhaps black with a purple sheen. Imagine 1 billion years of turquoise oceans, 1 billion years of flat, eroded continents, 1 billion years of purple bacteria floating in the silence. The day length had stabilized at around 18 or 19 hours. The moon was further away now. This was the teenage years of the Earth, a long, sullen, quiet period where the planet was just waiting. Life was there. The first eukaryotic cells with a nucleus, had evolved. They were more complex than the bacteria. They were the ancestors of all plants, animals, and fungi, but they were microscopic. They floated in the water, invisible to the naked eye. They did not build shells. They did not build bones. They left almost no fossils. They just existed. Floating, dividing, floating, dividing. If you were a time traveler visiting the boring billion, you would be bored, and that is a good thing. It would be the most peaceful vacation imaginable. You could sit on a flat, barren rock by a turquoise sea for 1 million years, and the only change you would see is the slow movement of the sun and the moon. The atmosphere had very little oxygen compared to today, perhaps only 1 or 2%. The air would be unbreathable for us, but the sky was blue, the sun was getting brighter. The stage was being set very, very slowly for the next act. Section 4, the great silence of the cryogenian. We are drifting forward now, leaving the turquoise tranquility of the boring billion. We are approaching 720 million years ago. The tectonic plates, which had been clustered together in the supercontinent Rodinia, began to pull apart. It was a slow divorce. Great rifts opened in the crust. Magma welled up, pushing the continents away from each other. As the land masses separated, they created new coastlines. And with new coastlines came rain. The rain fell on the fresh, jagged rock, and a chemical reaction took place. The water bound with the rock, pulling carbon dioxide out of the atmosphere and locking it away in the stone. The Earth's blanket was being stripped away. The greenhouse effect weakened. The planet began to cool. It started at the poles. The ice caps grew. Year by year, century by century, they crept closer to the equator. Ice reflects sunlight. It acts like a giant mirror. The more ice there was, the more sunlight was bounced back into space, and the colder the planet became. It was a loop, a feedback loop of cooling. This led to the Cryogenian period. The name comes from the Greek word for cold, and it was a cold unlike anything we have known since. This is the time of the snowball Earth. Imagine the silence. We have spoken of the silence of the void and the silence of the barren rock, but the silence of the snowball Earth was different. It was a muffled, heavy silence. The silence of deep winter. The ice sheets met at the equator. The entire planet from the North Pole to the South Pole was encased in a shell of ice. Some scientists believe this shell was half a mile thick. Others think it was thin and slushy in places. But for a long time, the open blue ocean was gone. The waves stopped. The rhythmic crashing of the surf, which had been the heartbeat of the planet for 3 billion years, ceased. The ocean was sealed. Under the ice, the water was dark and still. The currents slowed down. The mixing stopped. On the surface, the world was blindingly white. If you stood on the equator 700 million years ago, you would not see a tropical jungle. You would see an endless plain of ice, white and blue, stretching to the curve of the horizon. The sky above was incredibly clear. Because the oceans were frozen, there was very little evaporation. The water cycle had almost stopped. There were few clouds. The air was dry and brittle. The sun shone down from a hard azure sky onto the glittering ice. The wind was the only thing that moved. It howled over the frozen dunes, unimpeded by trees or mountains. It carved the ice into strange, sharp shapes. Sastrugi, ridges of hard snow, rippled across the landscape. For millions of years, the Earth was a white, frozen marble floating in the black of space. Life did not die, but it went into a deep slumber. The microscopic life, the algae, the bacteria, retreated. They found refugia, tiny pockets of liquid water, perhaps near volcanic islands where the heat of the Earth kept the ice thin, perhaps deep underwater near hydrothermal vents. They waited. They slowed their metabolism. They lived in the dark, cold water, preserving the spark of life in a world that had turned into a tomb. This freeze lasted for 50 million years. 50 million winters stacked one on top of another. It is a length of time that is hard to hold in the mind. It is long enough for mountains to rise and fall. But under the ice, nothing changed. The land was protected from erosion. The glaciers were cold-based, meaning they were frozen to the ground. They didn't grind the rock. They just sat there, heavy and still. But the Earth is alive on the inside. Beneath the frozen crust, the mantle was still churning. The core was still hot. Volcanoes continued to erupt. Imagine a volcano bursting through the ice sheet, a plume of gray ash rising into the clear blue sky. Red lava flowing out onto the white snow, hissing and steaming. The volcanoes pumped carbon dioxide into the atmosphere. Usually rain would wash this gas out of the air, but there was no rain. There was only ice. So the gas stayed there. It built up, year after year, million years after million years. The atmosphere grew thick with carbon dioxide. It became a heavy, heat-trapping blanket. The greenhouse effect began to return. And then, quite suddenly in geological terms, the tipping point was reached. The heat trapped by the atmosphere became strong enough to melt the ice at the equator. The melt began. It was catastrophic and beautiful. The ice cracked. Great fissures opened up, revealing the dark water beneath. As the dark water was exposed, it absorbed the sunlight. The warming accelerated. The snowball Earth collapsed into the hothouse Earth. The ice vanished. In its place, violent storms raged. The oceans, effectively stagnant for millions of years, began to churn. Massive hurricanes fed by the extreme heat contrast scoured the planet. The evaporation was intense. The rains returned, but they were torrential. The water washed over the continents, stripping away the debris left by the glaciers. It washed vast amounts of minerals, phosphorus, calcium, magnesium, into the sea. This runoff created a layer of rock that we can still see today. It is called the cap carbonate, a distinct layer of limestone that sits directly on top of the glacial debris. It is the geological mark of the Great Thaw, a line in the stone that says, "Here, the winter ended." And in the warm, nutrient-rich oceans that followed, life woke up. Section 5. The Ediacaran Garden. We have arrived at 635 million years ago, the beginning of the Ediacaran period. The world is warm. The seas are vast and shallow. The days have lengthened to perhaps 21 hours. The moon has drifted a little further away. In these warm, sunlit waters, something miraculous happened. Life got big. For 3 billion years, life had been microscopic, invisible to the naked eye. But now, in the nutrient-rich waters after the Great Melt, cells began to stick together in complex ways. They organized themselves. They built tissues. They became the Ediacaran biota. These were the first true animals. But they were nothing like the animals we know today. They were soft. They were quiet. They were peaceful. Paleontologists often call this time the Garden of Ediacara. It was a garden because there were no predators. There were no jaws, no teeth, no claws, no hard shells. Nothing was hunting anything else. It was a world of soft shapes drifting in the current. Let us wade into the shallow Ediacaran Sea. The water is clear and turquoise. The floor of the ocean is not sand. It is covered in a thick, leathery mat of microbes. It feels like a slimy, organic carpet. Lying on this carpet are the creatures. Look at Dickinsonia. It looks like a quilted mattress, flat, oval, and segmented. Some are small, the size of a coin. Others are huge, nearly 5 feet long. They lay flat on the sea floor, motionless. They did not have mouths. They did not have intestines. They simply absorbed nutrients through their bottom skin, digesting the microbial mat beneath them. They were soft creatures in a hard world. If you touched one, it would feel like a wet balloon or a jellyfish stranded on the beach. But they were not jellyfish. They were something entirely unique, an experiment in life that has vanished. Look at Charnia. It looks like a fern frond or a feather standing upright in the water. It was rooted to the sea floor by a disc. The frond swayed gently back and forth with the rhythm of the waves. Left, right, left, right. It looked like a plant, but it lived in deep water where there was no sunlight. It was an animal, filtering food from the water in total silence. There were creatures called Tribrachidium. They were small, round discs with 3 spiraling arms like a Triskelion symbol. They sat on the bottom, passively guiding water into their bodies. There were Kimberella. These were slightly more active. They looked a bit like slugs with a frilled skirt. They had a proboscis, a snout, that they used to scratch the microbial mat. They grazed. Slowly, methodically, they crept along the sea floor, leaving scratch marks in the slime. These scratch marks are some of the first evidence of animal movement in history. But even this movement was slow. There was no need to run. There was nothing to run from. The Ediacaran world was a world of sensory deprivation compared to ours. There were no eyes. No creature in the Ediacaran ocean could see. They lived in a world of touch and chemical signals. They felt the current. They tasted the water. But they never saw the sun or the moon or each other. There was no sound, no clicks, no grunts, no splashes of struggle. Just the fluid sound of water moving over soft bodies. It was a golden age of peace. a long, soft dream before the waking up of the modern world. These creatures thrived for nearly 90 million years. They spread across the globe. We find their fossils in Australia, in Newfoundland, in Russia, in Namibia. They were everywhere. They were the failed experiment of multicellular life. Or perhaps not failed, but simply different. They were fractals of life. Their bodies were built on a repeating pattern like a fern or a snowflake. As the Ediacaran period drew to a close, the chemistry of the ocean began to change again. The oxygen levels rose higher. The water became rich in calcium carbonate, the stuff of shells. And somewhere in the genetic code of a tiny worm-like creature, a switch was flipped. A plan was made for a hard part, a tooth, a spine, a shell. The garden was about to close. The first predators were evolving. The peace of the Ediacaran was ending, not with a bang, but with a crunch. Section 6. The Cambrian Rising. We move now to 541 million years ago. We are crossing the most famous boundary in geology, the start of the Cambrian period, the start of the Phanerozoic Eon, which means visible life. The world was changing. The supercontinent Pannotia was breaking apart. The sea levels were rising. Vast, shallow tropical oceans flooded the continents. These were the Epiric seas. They were warm, sunlit, and rich in minerals. And in these seas, the Cambrian explosion occurred. It is called an explosion, but in the slow time of geology, it took 20 million years. It was a flowering, a sudden burst of creativity. The animals developed armor. They pulled the calcium out of the water and built fortresses around their soft bodies. Trilobites appeared. These are the icons of the Cambrian. They looked like woodlice or horseshoe crabs with segmented armored backs. They scuttled across the sea floor on dozens of tiny legs. And they had something new, something that had never existed on Earth before. Eyes. The trilobites developed crystals of calcite, clear rock, and used them as lenses. For the first time in 4 billion years, the universe could look at itself. The trilobite looked up and saw the shimmering surface of the water. It looked sideways and saw the swaying fronds of seaweed. It saw the predator approaching. The silence of the ocean was broken by new sounds. The clatter of hard shells bumping against rocks, the crunch of predation. There was Anomalocaris, the strange shrimp. It was the giant of the Cambrian seas, perhaps 3 feet long. It drifted through the water like a graceful alien ship. It had large, compound eyes on stalks. It had 2 spiny, grasping appendages in front of its mouth. It was the first apex predator. It swam with undulating flaps along its sides, a rhythmic ripple of movement. There was Opabinia, a bizarre creature with 5 eyes and a long nozzle like a vacuum cleaner hose. It used the nozzle to probe the mud for food. There was Hallucigenia, a worm-like creature with long, thin spines on its back and spindly legs. It looked like a surrealist painting come to life. The seafloor changed. In the Ediacaran, the floor was a firm microbial mat. In the Cambrian, the animals began to burrow. They dug into the mud. They churned it up. This is called the agronomic revolution. The worms and arthropods mixed the sediment, destroying the old mats and creating a soft, muddy bottom. The water was filled with life. Sponges grew in colorful reefs, filtering the water. Brachiopods, creatures that looked like clams, anchored themselves to the rocks. But the land was still silent. If you walked along the Cambrian coastline, you would see no trees, no bushes, no grass, no moss. The continents were brown and gray, barren rock and sand. There was no soil because soil is made by plants and bugs, and they hadn't arrived yet. The rivers didn't flow like modern rivers. Without plant roots to hold the banks together, the rivers were wide, braided sheets of water. They washed sand and silt into the ocean in vast quantities. The air was breathable now. The oxygen levels were rising, though still lower than today. The days were about 21 hours long. The year was 420 days long. The Earth was spinning faster. The tides were frequent. Let us rest here for a moment in the Cambrian. Imagine sitting on a warm, rocky beach. The sun is bright. The waves lap at your feet. In the water, strange, armored shapes scuttle through the clear shallows. Behind you, a desolate, empty continent stretches to the horizon. It is a world of contrast, a teeming, violent, colorful ocean, and a silent, dead land. But the life in the water was pushing at the edges. The tide pools were full of activity. The algae were creeping up the wet rocks. The greening of the earth was about to begin. Section 7. The Ordovician Drift. We drift forward another 50 million years. It is the Ordovician period beginning 485 million years ago. The climate was warm. It was a greenhouse world. The sea levels were incredibly high, the highest they have been in the entire Paleozoic era. The continents were flooded. North America was almost entirely underwater, transformed into a tropical sea teeming with life. If you could sail a boat over Ordovician North America, you would see a bottomless blue depth in some places and shallow coral-like reefs in others. But they weren't coral reefs. They were built by sponges and creatures called bryozoans. The kings of this sea were the orthocones. These were the ancestors of the squid and the octopus. But unlike the modern octopus, they had shells, long, straight, cone-shaped shells. Some were small, the size of a carrot. Others were massive, growing up to 20 or 30 feet long. Imagine a giant living spear floating in the water. At the front, a cluster of tentacles and a beak. At the back, a long, rigid shell. They drifted silently, using jets of water to propel themselves. They were the submarines of the ancient world. The seafloor was carpeted with crinoids. These are animals related to starfish, but they look like flowers. They are often called sea lilies. They had long stems anchored to the seafloor and feathery arms that opened up to catch food. Imagine a forest of sea lilies. Millions of them swaying in the gentle current, orange, yellow, red, and white, a garden of animals that looked like flowers. When a shadow passed over them, perhaps the shadow of a giant orthocone, they would curl up their feathers, hiding. Then slowly they would unfurl again. It was a slow, hypnotic movement. Open, close, open, close. On land, the first pioneers were arriving. They were not trees. They were not even bushes. They were simple, non-vascular plants, liverworts, mosses, tiny green fuzz growing on the wet rocks near the water's edge. They were silent conquerors. They released spores into the wind. The spores drifted inland, finding damp shadows to grow. Slowly, a green stain began to spread across the gray continents. With the plants came the first land animals, tiny millipedes. They were the first creatures to breathe air. They scurried through the damp moss, eating the rotting plant matter. They were the size of a grain of rice, but they were there, walking on the earth. The Ordovician ended in a slow tragedy. The supercontinent Gondwana drifted over the South Pole. Glaciers formed. The water was locked up in ice. The sea levels dropped. The vast shallow seas drained away. The habitats vanished. This was the first mass extinction, but in our sleepy history we view it not as a violent event but as a quiet closing of doors. The water receded. The sea lilies died. The giant straight-shelled nautiloids sank to the bottom. The world cooled. The ice returned, a short, sharp ice age to cleanse the palate before the next explosion of life. Section 8. The Silurian and the Whispering Stems. The ice of the Ordovician melted away. The glaciers that had gripped the South Pole retreated, turning back into water, flowing back into the sea. We enter the Silurian period 443 million years ago. The world warmed up. The sea levels rose again, soothing the scars of the Ice Age. The shallow tropical seas returned, clearer and calmer than before. If you stood on the shore in the Silurian, the light would seem particularly bright. The atmosphere was stabilizing. The days were getting longer, inching toward 22 hours. In the oceans, the reefs recovered. But these were not just reefs of sponge anymore. Now there were corals. The tabulate corals and rugose corals. They built honeycombed structures, calcium castles in the warm water. They grew slowly, polyp by polyp, extracting minerals from the sea. Swimming among these reefs were the eurypterids, the sea scorpions. Imagine a scorpion but the size of a human being, or larger. Some grew to be 8 feet long, but do not imagine them as fast or aggressive. In the heavy, buoyant water, they were graceful. They had broad, paddle-like limbs for swimming. They drifted through the shallow lagoons, their segmented bodies undulating gently. They were the top predators, but they moved with a lethargic confidence. They would settle on the sandy bottom, kicking up a small cloud of silt, and wait. They were the silent sentinels of the Silurian. Their hard exoskeletons were heavy, grounding them in the world of water. But the true story of the Silurian is not in the water. It is on the land. For 4 billion years, the continents had been silent and gray, rock, sand, and dust. But now a new color was creeping across the landscape, green. The mosses had arrived earlier, hugging the wet rocks. But now plants were learning to stand up. They were evolving vascular tissue, tiny pipes inside their stems to carry water up from the ground. This allowed them to grow taller than a carpet. Meet Cooksonia. It is the oldest known plant to have a stem. It did not look like a tree. It did not look like a bush. It looked like a tiny green branching stick no taller than your pinky finger. It had no leaves. It had no roots, just tiny hairs anchoring it to the mud. It had no flowers. Just a green Y-shaped stem with little spore capsules on the tips. Imagine a vast flat floodplain near the ocean. The mud is wet and dark, and covering this mud are millions of Cooksonia, a miniature forest only 2 inches high. Because they had no leaves, they did not rustle. But if a breeze blew across the floodplain, it would make a faint whistling sound as it passed through the millions of tiny stems. A soft, high-pitched hiss. Shh. This was a new sound. The wind had blown over rocks for eons, making a hollow, lonely sound. Now it had something to play against. The earth was beginning to whisper. In this miniature forest, life was microscopic. Tiny mites and millipedes climbed the green stems. They were the first pioneers of the vertical world. They lived their entire lives in a jungle that was only an inch tall. The Silurian was a short period, geologically speaking, only 24 million years. But it was the bridge. It was the time when the land accepted the touch of life. Section 9. The Devonian and the Deep Shade. We drift forward into the Devonian period 419 million years ago. This is often called the Age of Fishes, but it could also be called the Age of the First Forests. The plants were figuring out how to grow. They solved the engineering problems of gravity. They developed wood. Wood is a hard, fibrous material called lignin. It allowed plants to build stiff trunks, to reach up, to compete for the light. And so, the canopy rose. From the ankle-high Cooksonia, we moved to the knee-high ferns and then to the Archaeopteris. This was the first true tree. It grew up to 90 feet tall. It looked a bit like a Christmas tree with fern-like fronds instead of needles. For the first time in history, there was shade. Think about that. For 4 billion years, the sun had struck the ground with full force. Now there were shadows. Cool, damp, dark patches of ground beneath the branches. In this shade, the humidity was trapped. The air remained moist. The ground itself changed. The roots of these great trees drilled down into the rock. They broke the stone apart. They secreted acids. They churned the earth. As the leaves died and fell, they rotted. This created soil, deep, rich, organic soil. The smell of the earth changed. It no longer smelled just of wet dust and rain. It smelled of loam. It smelled of fungi. It smelled of decay and growth. The smell of a forest after rain, petrichor, became a global scent. Standing among these first trees were the prototaxites. These are the strangest organisms to ever live on land. For a long time, scientists didn't know what they were. They looked like tree trunks rising 20 feet into the air. But they had no branches, they had no leaves. They were just pillars of organic matter. We now believe they were giant fungi, enormous mushrooms. Imagine a landscape where the trees are actually 20-foot-tall pillars of fungus towering over the low bushes. They were the slow decomposers feeding on the new soil, standing silent and still like obelisks. While the land was darkening with forests, the oceans were heavy with armor. The Devonian seas were ruled by the placoderms. These were armored fish. They didn't have scales, they had bony plates covering their heads and chests. They looked like knights built for underwater combat. The most famous was Dunkleosteus, a massive creature 30 feet long, weighing several tons. It did not have teeth. Instead, the bones of its jaw were sharpened into self-polishing shearing blades. But let us view Dunkleosteus not as a monster, but as a masterpiece of biological engineering. It was heavy. It was not a fast, darting swimmer like a modern tuna. It moved with the momentum of a submarine. It cruised the deep reefs, its heavy tail sweeping side to side in a slow rhythm. The sound of the Devonian Ocean was the click and clatter of bone against bone, the heavy thud of armored fish bumping into the coral. And in the shallow, muddy waters at the edge of the river deltas, something else was happening. A fish called Tiktaalik was testing the boundaries. Tiktaalik was a fishapod. It had scales and gills like a fish, but it had a flat head like a crocodile. And most importantly, inside its fins it had bones, a shoulder, an elbow, a wrist. It lived in the shallow, weed-choked waters where large, armored fish couldn't reach it. The water was low in oxygen. To survive, Tiktaalik developed primitive lungs. It would swim to the surface, gulp air, and sink back down. Sometimes the water would get too shallow. Or perhaps there was a dead insect on the mud bank that looked tasty. So Tiktaalik did a push-up. It planted its fleshy fins in the mud. It pushed down. Its shoulders held. It dragged its heavy body out of the water and onto the wet earth. Feel the weight. For its entire life, the water had supported it. Now gravity pulled at its organs. Its skin felt dry. The light was harsh. The air was thin. It didn't run. It didn't walk. It dragged itself inch by inch. Belly sliding over the mud. Slither, rest, slither, rest. It was exploring a world that was empty of vertebrates. There were plenty of bugs, millipedes, spiders, scorpions, but no other backboned animals. The Tiktaalik was an astronaut on a new planet. It would linger on the mud for a while, perhaps catching a centipede, and then slide back into the comforting embrace of the water. This was not a singular event. This happened over millions of years. Thousands of generations of fish pushing themselves up, strengthening their limbs, spending a little more time in the air, a little less time in the water. The fins became legs. The swim bladder became lungs. The fish became tetrapods. Amphibians. They were tied to the water. Their skin needed to stay wet. Their eggs had to be laid in water like frog spawn. But they were free of the ocean. They could crawl into the dark, damp shade of the Archaeopteros forests. They could sleep under the giant fungal towers. Section 10. The Late Devonian Extinction. The Devonian was a time of growth, but it ended in silence. Ironically, the trees might have caused the crisis. The Devonian plant hypothesis. The new forests were so successful that their roots pumped vast amounts of nutrients into the oceans. Phosphorus and nitrogen washed from the soil into the sea. This caused massive algae blooms. The algae grew, died, and rotted. The rotting process used up all the oxygen in the water. The oceans became anoxic, they suffocated. The great armored fish, the dunkleosteus, the trilobites, the reefs, they began to die. It wasn't a sudden asteroid impact. It was a slow suffocation, a Kellwasser event. The deep oceans turned black and lifeless. The world cooled down again. The trees had sucked so much carbon dioxide out of the air that the greenhouse effect collapsed. Glaciers returned to the poles. For 20 million years, the Earth struggled. The diversity of life dropped. The heavy armored fish disappeared forever, leaving the seas to the sharks and the bony fish, the ancestors of the goldish and the tuna. But on land, the tetrapods survived. They huddled in the wet refuges. They waited. As the Devonian closed, the continents were drifting together. They were moving toward a reunion. North America and Europe were colliding. The crust buckled and folded. The Appalachian Mountains were rising. Today they are old, rounded, gentle hills. But when they were born in the Devonian, they were jagged and high, rivaling the Himalayas. But there was no one to see them. Just the wind, the rain, and the slow, crawling amphibians moving through the valleys. The stage was set for the Carboniferous. The world was about to become a swamp. A giant, humid, oxygen-rich swamp where life would grow to monstrous proportions. Section 11. The Carboniferous hum. The Earth continued to spin. The continents drifted closer together. We enter the Carboniferous period 359 million years ago. The name Carboniferous means coal-bearing. This was the era that built the bedrock of the industrial world. But long before it was fuel, it was a forest so vast, so dense, and so wet that it covered nearly the entire tropical belt of the planet. The climate was hot and incredibly humid. If you stepped out of a time machine into a Carboniferous swamp, the first thing you would notice is the air. It was thick, it was heavy, and it was rich. Oxygen levels were climbing. Today, our atmosphere is 21% oxygen. In the Carboniferous, it peaked at perhaps 35%. The air was intoxicatingly pure. It allowed fires to burn hotter and brighter, but in the wet swamps, fire was rare. Instead, there was growth. The trees here were alien. You would not recognize them. There were no oaks, no pines, no maples. These were lycopods, giant club mosses. Look at the lepidodendron, the scale tree. It grew 150 feet tall. But its trunk was not made of wood and bark like a modern tree. It was covered in diamond-shaped scales arranged in perfect spirals. These were the scars where leaves had fallen off as the tree grew. The trunk was green, photosynthesizing all the way up. At the very top, it split into a crown of grassy branches. There was Sigillaria, another giant which looked like a tall green column topped with a mop of long grass-like leaves. It looked like a bottle brush reaching for the sky. The roots of these trees were shallow. They spread out sideways through the waterlogged peat. The ground was soft, spongy, and deep. Every step you took would sink a few inches into the wet moss. Because the trees grew fast and had shallow roots, they fell over often. The swamp floor was a tangle of fallen logs. But here is the secret of the Carboniferous. Nothing was eating the trees. Fungi and bacteria had not yet evolved the enzymes necessary to digest lignin, the hard stuff in wood. So when a tree fell, it didn't rot. It didn't disappear. It just sank into the mud. Another tree grew on top of it, then another. layer upon layer of unrotted wood built up over millions of years. The carbon they had pulled from the air was trapped in the mud. Compressed by the weight of time, this wood turned into peat, then into lignite, and finally into black, hard coal. The energy you see when you burn a piece of coal is fossilized sunlight from 300 million years ago. It is the stored memory of a carboniferous summer. In this high-oxygen atmosphere, the animals changed. The insects, in particular, responded to the rich air. Insects breathe through tiny tubes in their bodies. In our world, their size is limited by how much oxygen can diffuse through those tubes. But in the Carboniferous, with so much oxygen, they could grow, and they grew giants. Imagine a dragonfly called Meganeura. It had a wingspan of 2.5 feet. It was the size of a hawk eagle, but it didn't screech, it hummed. The sound of the Carboniferous was a deep, resonant drone, the beating of giant wings. Thrum, thrum. It was a low-frequency vibration that you would feel in your chest as much as here. Meganeura was a predator, patrolling the glades between the scale trees, hunting smaller insects. On the forest floor, weaving through the giant ferns, was Arthropleura. This was a millipede, but it was 8 feet long and 2 feet wide. It was the size of a crocodile. It was an herbivore. It moved slowly, its hundreds of legs rippling in a wave-like motion. Tick, 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 the sound of its armor brushing against the fallen leaves. It was heavy, peaceful, and almost armor-plated. It had no enemies. It simply grazed on the rotting vegetation, a gentle giant of the undergrowth. The amphibians were thriving too. They had grown large. Eogyrinus was an amphibian that was 15 feet long, moving through the swamp water like a giant eel. These creatures were tied to the water, laying their jelly-like eggs in the pools. The days were getting shorter again, as the Earth's rotation slowed down slightly. But the nights in the Carboniferous swamp were never truly dark. The moon was bright, and the biological light was everywhere. Bioluminescent fungi glowing on the rotting logs. Fireflies the size of sparrows blinking in the canopy. It was a glowing, humming, wet, green world. A world of excess. Section 12. The Permian Solitude. The swamps could not last forever. The climate began to change. We move into the Permian period 299 million years ago. The continents finally collided. They smashed together to form the most famous supercontinent of all, Pangaea. Pangaea. All Earth, one giant landmass stretching from pole to pole. As the continents merged, the inland seas were drained. The mountains rose higher, and the vast, humid swamps of the Carboniferous dried up. The Carboniferous rainforest collapse occurred. The scale trees died out, replaced by hardier plants. Conifers, ginkgos, seed ferns, plants that could tolerate the dry air. The center of Pangaea became a vast desert. It was too far from the ocean for rain clouds to reach. It was a world of red sand, red rock, and shimmering heat. The oxygen levels dropped. The giant insects disappeared, unable to breathe. The hum of the Meganeura faded into silence. But in this drier world, a new kind of animal rose to power: the amniotes. These were animals that had developed a special kind of egg, an egg with a hard, leathery shell, an egg that held its own water inside. Unlike the amphibians who had to return to the water to lay their eggs, the amniotes could lay their eggs on dry land. They were free. They could walk into the heart of the desert. The rulers of the Permian were not dinosaurs. Dinosaurs had not evolved yet. The rulers were the synapsids. We often call them mammal-like reptiles, but they were the ancestors of mammals. They were our great-great-great-grandfathers. The most famous was Dimetrodon. You know this creature. It walked on 4 legs, low to the ground. It had a long tail and a large head filled with teeth. But on its back it carried a magnificent sail. huge spines of bone connected by a web of skin. Imagine a Dimetrodon waking up in the cool Permian morning. The sun is rising over the red rocks of Pangaea. The air is cold. The animal is sluggish. Its blood is thick and slow. It turns its body sideways to the sun. It orients its sail to catch the light. The blood pumps through the thin skin of the sail, warming up rapidly in the solar rays. This was a solar panel made of skin. As it warmed up, the Dimetrodon gained energy. It became active while other creatures were still cold and slow. It was a master of thermodynamics. The Permian world was a world of slow movements. The herbivores, like the Edaphosaurus, which also had a sail, or the cow-sized Moschops, lumbered through the scrubland. Moschops was a thick, heavy creature with a sloped back and a thick skull. It grazed on tough, low bushes. There was no grass yet. The ground was covered in ferns and mosses, or it was bare, baked earth. The seasons in Pangaea were extreme. Because the landmass was so huge, the summers were incredibly hot, and the winters were bitterly cold. Mega monsoons swept across the coastlines, dumping torrential rain for months, followed by months of total drought. Life had to be tough. It had to be patient. Many animals likely dug burrows to escape the heat of the midday sun. They would sleep in the cool earth, waiting for the twilight. It was a rugged, rusty-colored world. A world of endurance. Section 13. The Great Dying. We have reached the end of the Paleozoic era, 252 million years ago. The end of the Permian. This is the quietest moment in the history of the Earth. It is called the Permian-Triassic Extinction Event, or simply, the Great Dying. It began in Siberia. The ground opened up. Not a volcano like Mount St. Helens, which explodes. This was a flood basalt eruption, the Siberian Traps. Deep cracks in the Earth's crust, miles long, began to weep lava. The lava flowed and flowed. It covered an area the size of the United States. It flowed for 1 million years. The lava burned through vast coal deposits, the buried forests of the Carboniferous. This released unimaginable amounts of carbon dioxide and methane into the atmosphere. The temperature skyrocketed. The Earth warmed by perhaps 10 degrees Celsius. The poles melted. The ocean circulation stopped. When the ocean currents stop, the water becomes stagnant. It loses its oxygen. The deep oceans turned anoxic again. The pink bacteria and purple sulfur bacteria returned. The seas turned from blue to a murky, toxic pink. Hydrogen sulfide gas bubbled up from the depths. It is a gas that smells like rotten eggs and is lethal to breathe. It drifted over the shores of Pangaea. The animals died. It was not a violent cinematic death. It was a slow fading away. The Dimetrodon lay down in the shade of a rock and did not get up. The coral reefs bleached and crumbled. The trilobites, who had scurried across the sea floor for 300 million years, finally vanished. 95% of all life in the ocean died. 70% of all life on land died. It was the closest the Earth has ever come to becoming a dead planet like Mars. The forests disappeared. The coal gap began, a period of millions of years where no coal was formed because there were no trees to make it. The fungal spike occurred, a layer of rock filled with fungal spores feasting on the decaying matter of the world. And then, silence, a profound global hush. The wind blew over empty deserts. The waves lapped against silent shores. The sun beat down on a Pangaea that was almost devoid of movement. But almost is the key word. In the burrows deep underground, a few things survived. Look at Lystrosaurus. It was a synapsid, a relative of the mammals. It looked like a pig mixed with a lizard. It had 2 tusks, a beak, and a barrel-shaped body. It was not pretty. It was not majestic. It was a digger. It survived the heat, the bad air, and the starvation by hunkering down. It ate anything: roots, tubers, dead plants. It lived in the dark. When the worst of the dying was over, Lystrosaurus poked its head out of its burrow. It blinked in the harsh sunlight. It looked around at the empty world. It was the inheritor of the earth. For the next few million years, Lystrosaurus was everywhere. In some fossil beds, 90% of the bones found are just this one animal. It waddled across Pangaea, grazing in the ruins, repopulating the planet. It is a sleepy image. Herds of pig lizards wandering slowly through a desolate landscape, the only sound their grunting and the shuffling of their feet in the dust. The Paleozoic was over. The ancient life had passed. The slate had been wiped clean. The earth took a long, deep breath. It needed time to heal. It needed time to cool. The recovery would be slow. It would take 10 million years for the ecosystems to rebuild, but life is stubborn. Life is patient. In the emptiness, new seeds were sprouting. The ancestors of the turtles, the ancestors of the crocodiles, and small and quick, the ancestors of a new group that would come to rule the world for the next 150 million years. The archosaurs, the ruling lizards. The dinosaurs were coming. But for now, let us leave the earth in its quiet state, the red dust settling, the pink ocean slowly turning blue again, the lone Lystrosaurus sleeping in the sun. The planet is resetting its clock. Section 14, the Triassic dawn and the long rain. The great dying faded into the past. The earth, resilient and patient, began to wake up again. We enter the Triassic period starting 252 million years ago. It was a slow dawn. For millions of years, the planet was still healing. The heat was intense. Pangaea was a vast, dry supercontinent shaped like a giant sea curving around the Tethys Ocean. In the center of Pangaea, far from the cooling touch of the sea, the deserts were endless. Red sand dunes shifted slowly in the wind. The silence was profound. There were few trees here, just the heat shimmering off the ground, distorting the horizon. But life was returning. It started small. In the shadows of the rocks, the archosaurs, the ruling lizards, were evolving. They were splitting into two groups. One group would become the crocodiles. The other group would become the dinosaurs. But the early dinosaurs were not giants. They were small, quick creatures like Eoraptor or Chelophysis. They were the size of a dog or a pony. They hunted in the scrubland, light on their feet, waiting for their turn to rule. And then, something strange happened to the weather. About 232 million years ago, the sky darkened. Clouds gathered over the parched deserts of Pangaea. The humidity rose, and it began to rain. This was the Carnian pluvial episode. It sounds like a brief storm, but in the slow time of geology, an episode can last for ages. It rained for 2 million years. The deserts turned into mud. The dry gullies turned into rivers. The rivers turned into lakes. The red dust of the Triassic was washed away, replaced by gray, waterlogged soil. Listen to the sound of that rain. A steady tropical drumming that went on for thousands of generations. It changed the world. The plants loved it. The conifers exploded in population. The ferns returned. The world turned green again. And with the green came the giants. The influx of plants provided enough food for the dinosaurs to grow. They stopped being small scavengers. They began to bulk up. The first large herbivores appeared, the Plesiosaurus. It was an ancestor of the long-necked giants. It was bipedal, heavy and slow, reaching up to strip the leaves from the high branches. The rain washed away the old world and watered the seeds of the new one. When the clouds finally cleared 2 million years later, the dinosaurs had taken over. The age of the crocodile relatives was ending. The age of the dinosaur had truly begun. Section 15. The breaking of the world time drifts forward to 201 million years ago, the end of the Triassic. Pangaea, the great mother continent, could not hold together. The heat beneath the crust was too intense. The mantle was churning. The land began to tear. A great rift valley opened up. It stretched from what is now New York down to Morocco. It was a silent, slow-motion catastrophe. The ground sank. Lava welled up through the cracks. This was the Central Atlantic Magmatic Province. It was another flood basalt event, similar to the one that caused the Great Dying but slightly less severe. It pumped carbon dioxide into the air. It acidified the oceans. Many of the competitors of the dinosaurs died out in this pulse of heat and gas. The slate was cleared again. As the lava cooled, the rift widened. Water from the ocean spilled in. It filled the crack between the continents. This was the birth of the Atlantic Ocean. But it was not the vast ocean we know today. It was a narrow, shallow seaway, a long, thin strip of water separating North America from Africa. If you stood on the cliffs of New Jersey in the early Jurassic, you could look across the water and see the coast of Morocco. The breakup was gentle in its violence. Continents move at the speed that fingernails grow, 1 inch per year, 2 inches per year. The gap widened imperceptibly. But over millions of years, the separation became absolute. This split changed the climate again. Pangaea had been dry because the interior was so far from the sea. But as the ocean entered the heart of the landmass, it brought moisture. The humidity rose, the deserts retreated, the Jurassic period began. 199 million years ago, the world became a greenhouse, warm, wet, lush. There was no grass in the Jurassic. The ground was covered in ferns and horsetails. The forests were made of araucaria trees, the monkey puzzle trees, and cycads, which looked like stiff, woody palm trees. The air was heavy with the scent of pine resin and rotting vegetation. It was a golden age of stability, a long, warm summer that lasted for 50 million years. Section 16. The Jurassic Giants. In this warm green world, the dinosaurs let go of all restraint. They grew, and they grew, and they grew. This is the time of the sauropods, the long-necked giants, Diplodocus, Brachiosaurus, Apatosaurus. Let us observe a herd of Diplodocus moving through a Jurassic fern prairie. They are the most sleepy creatures in history. Imagine an animal that is 90 feet long. That is the length of 3 school buses parked end to end. It weighs 20 tons. Its legs are like the pillars of a temple, thick, straight, and solid. They do not run. They do not trot. They walk with a slow, rhythmic cadence. Thud, pause, thud, pause. When a foot comes down, the ground trembles. Not a violent shake, but a gentle, deep vibration that travels for miles through the soft earth. The sound of their walking is the bass rhythm of the Jurassic. Their heads are tiny compared to their bodies. They do not chew their food. They do not have the teeth for it. They simply rake the leaves off the branches with peg-like teeth and swallow them whole. The leaves travel down a neck that is 20 feet long. They enter a stomach that is the size of a fermentation tank. Inside the stomach, gastroliths, smooth stones the dinosaur swallowed on purpose, grind the food. Bacteria break down the tough plant matter. The digestion of a sauropod was a slow chemical furnace. It generated heat. These animals were massive heat sinks. They didn't need to warm up in the sun like the Dimetrodon. Their sheer bulk kept them warm. In fact, their problem was staying cool. That is why they moved slowly. If they ran, they would overheat. So they lived life in low gear. They spent their days eating, stripping a tree of its needles, then taking a slow step to the next one. They were living lawnmowers. Look at Brachiosaurus. It was different. It stood taller, its front legs longer than its back legs. It was built like a giraffe, but on the scale of a construction crane. It could reach 40 feet into the air. It stood in the forests, its head lost in the canopy, eating the highest leaves that no other animal could reach. It was an elevator of flesh and bone. The heart of a brachiosaurus was a marvel of biological engineering. To pump blood up that long neck to the brain, the heart had to be massive. It beat slowly. Thump-dub. Thump-dub. High pressure, low frequency. These herds were peaceful. Their size was their defense. A predator like Allosaurus might attack a sick or young individual, but a healthy adult sauropod was a walking fortress. They had no need for anxiety. They had no need for haste. They lived for perhaps 100 years. A century of slow walking. A century of eating. A century of looking down from the heights. The atmosphere of the Jurassic was rich in carbon dioxide, perhaps 5 times higher than today. This kept the planet warm. There were no ice caps. The poles were covered in forests. You could walk to the North Pole and stand under a redwood tree. Section 17. The Ocean Drifters. While the sauropods marched across the continents, the oceans were filled with their own slow giants. The Jurassic Ocean was a dangerous place, but it was also beautiful. The water was warm and blue. Here, the plesiosaurs roamed. Imagine a creature with the body of a turtle but without the shell, and a neck like a snake. Plesiosaurus. They swam with 4 large flippers. Unlike fish that swim by waving their tails, plesiosaurs flew through the water. They flapped their flippers like the wings of a bird. It was a graceful gliding motion. Stroke, glide, stroke, glide. They would cruise near the surface, their long necks reaching out to snap up fish. They didn't dive deep. They liked the sunlit waters. Deeper down, the ichthyosaurs ruled. These looked like dolphins, but they were reptiles. They had evolved the perfect shape for the water. Streamlined, smooth, and fast. But in the Jurassic, they began to get large. Temnodontosaurus, 30 feet long. They gave birth to live young in the water. They had cut all ties with the land, and floating everywhere in the water were the ammonites. These were the relatives of the squid, but they lived inside spiral shells. Some were small as a fingernail. Some were the size of a truck tire. They bobbed in the water column, controlling their buoyancy by pumping gas into the chambers of their shells. They were the decorators of the ocean. Their shells were ribbed and patterned. They drifted with the currents, millions of them, a slow, spinning regatta of shelled creatures. When they died, their shells sank to the bottom. They settled in the mud, layer after layer. Today, if you walk along the Jurassic coast in England, you can kick rocks and find them. Stone spirals locked in the gray shale, a memory of a slow drift in a warm sea. Section 18. The Stegosaurus Sunset. Late in the Jurassic, a specific shape appeared that every child knows. The Stegosaurus. It is the most famous dinosaur of the Jurassic after the long necks. It was a low-slung browser eating ferns and bushes. It carried a row of vertical plates along its back. These plates were not armor. They were too brittle. They were likely for display or for thermoregulation, like the sail of the Dimetrodon millions of years earlier. The Stegosaurus had a brain the size of a walnut. It was not a thinker. It was a reactor. It lived a life of pure instinct. Eat, sleep, swing the tail. The tail had 4 spikes. The Thagomizer. It was a formidable weapon, but the animal itself was quiet. It moved slowly through the underbrush. As the sun set on the Jurassic period 145 million years ago, the world was changing again. The continents were drifting further apart. The Atlantic was widening. The climate began to cool slightly, not into an ice age, but enough to change the vegetation. The great age of the sauropods was peaking. They would continue into the Cretaceous, but they would never be quite as dominant as they were in the mid-Jurassic. The ferns were giving way to new types of plants. The reference time for the Earth was shifting. The continents were beginning to look vaguely familiar. You could spot Africa. You could spot South America, though they were just unzipping from each other. The Earth spun on. The moon was a little further away. The tides were a little gentler. The days were a little longer. The Jurassic ended quietly. There was no mass extinction event that marked the boundary. Just a slow transition, a fade from one chapter to the next. The stage was set for the final act of the dinosaurs, the Cretaceous, the time of the flowers, the time of the tyrant lizard king. But that is a story for the next drift. For now, let us stay in the Jurassic twilight, the silhouette of a Brachiosaurus neck against the purple sky, the sound of heavy feet on soft earth, the smell of pine and damp fern, the deep, slow heartbeat of a world at peace with its own size. Section 19. The Flowering of the World. We drift into the Cretaceous period 145 million years ago. The name comes from the Latin word creta, meaning chalk. This is the time that built the white cliffs of Dover, the time of the great chalk seas. But the most profound change in the Cretaceous was not in the rocks. It was in the smell of the air. It was in the color of the ground. For 4 billion years, the earth had been green and brown, mosses, ferns, pines, cycads, but it lacked the delicate, vibrant colors of the spectrum. There were no reds, no purples, no yellows dotting the landscape. And then, quietly, the angiosperms appeared. The flowering plants. It started in the dark undergrowth of the Jurassic forests, but in the Cretaceous they exploded. They invented a new way to reproduce. Instead of relying on the wind to carry their pollen, a chaotic and wasteful method, they enlisted help. They evolved nectar, sugar water, a bribe, and the insects responded. The bees and the butterflies evolved alongside the flowers. It was a slow, coordinated dance of coevolution. The flower changed its shape to fit the bee. The bee changed its tongue to fit the flower. Imagine the sensory shift. Walking through a Cretaceous forest, you would suddenly smell something sweet. The scent of magnolia, the scent of lily pads. The air was no longer just damp and resinous. It was perfumed. The ground was no longer just needles and dirt. It was carpeted with petals. White star-shaped flowers opening in the morning light, yellow cups catching the rain. This was the Cretaceous terrestrial revolution. It changed the energy of the planet. Flowers grow faster than pine trees. They cycle nutrients faster. The metabolism of the forests sped up. The sun's energy was being processed more efficiently. Among these flowers walked the ankylosaurs, the living tanks. Picture Ankylosaurus. It was a low, wide creature built like a coffee table made of bone. It was covered in osteoderms, bony plates embedded in its skin. Even its eyelids were armored. It was the ultimate defensive sleeper. It didn't need to run. It didn't need to fight. If a predator approached, it simply hunkered down, pulling its legs under its shield. It became a rock. It grazed on the low-growing flowering plants. It was one of the first animals to taste the sweetness of a flower. It moved with a slow, waddling gait, swinging its heavy club tail behind it. A peaceful, armored gardener in a world that was suddenly bursting with color. Section 20. The Splitting of the South. While the flowers bloomed, the map of the world was being redrawn. Gondwana, the great southern supercontinent, was breaking apart. South America and Africa, which had been locked in a tight embrace for hundreds of millions of years, began to unzip. The rift started in the south and moved north. It was a slow tearing of the crust. As they separated, the South Atlantic Ocean was born. It began as a series of long, narrow lakes like the Rift Valley lakes in East Africa today. Then salt water flooded in. The ocean was young, narrow, and restricted. The circulation was poor. In the stagnant, salty waters of the early South Atlantic, vast amounts of algae and plankton grew and died. They rained down onto the sea floor, burying themselves in the black mud. Layer after layer of organic sludge. Over millions of years, the heat of the earth cooked this sludge. It turned it into oil. The oil fields off the coast of Brazil and West Africa today are the remains of that Cretaceous rift. They are the liquid ghosts of a stagnant sea. The separation continued. India broke loose from Madagascar and began its long, lonely voyage north across the Indian Ocean. It was an island continent carrying its own unique cargo of dinosaurs, drifting slowly toward Asia. Australia began to peel away from Antarctica, but they remained connected for a long time, a bridge of forest near the South Pole. The climate was incredibly warm. There was no ice at the poles. The temperature difference between the equator and the poles was small. The Cretaceous hothouse. Because the poles were warm, the ocean currents were sluggish. Cold water sinks and drives the circulation of the oceans. Without cold water, the oceans became calm, stratified, and sleepy. The oceanic anoxic events returned periodically, times when the deep ocean lost its oxygen and turned black and still. Section 21, the Western Interior Seaway. Let us focus on North America. In the late Cretaceous, you could not walk from New York to California. The continent was cut in half. A vast, shallow sea stretched from the Arctic Ocean down to the Gulf of Mexico. The Western Interior Seaway. It was a warm, turquoise ocean, perhaps only 600 feet deep. It covered Kansas, Nebraska, the Dakotas, Colorado. If you sailed over Kansas 80 million years ago, you would be surrounded by water. Below you, the bottom was soft, chalky mud. This mud is what preserved the fossils so perfectly. In this seaway lived the archelon, the largest turtle of all time. It was the size of a car. It had a leathery shell and vast flippers. It swam with the slow, gliding grace of a sea turtle, but on a massive scale. There were giant clams called Inoceramus. They were flat and plate-like, some as big as a bathtub. They lay on the muddy bottom, filtering the water. They were so large that small fish would hide inside them. And patrolling these waters were the mosasaurs. These were not dinosaurs. They were giant marine lizards, related to modern monitor lizards and snakes. They had long, sleek bodies and paddle-like limbs. Tylosaurus grew to 45 feet long. Imagine a mosasaur cruising through the sunlit water of Kansas. It didn't swim with the frantic energy of a shark. It swam with a serpentine undulation, S-curves, quiet, deadly. The seaway was a place of abundance, but it was also a place of calm. The storms that swept across it would stir up the chalk, turning the water milky white. Then the calm would return and the chalk would settle, coating the bottom in another millimeter of white dust. On the western shore of this seaway, in what is now Utah and Montana, the dinosaurs reached their peak diversity. This was the coastal plain of Laramidia, a narrow strip of land sandwiched between the mountains and the sea. Here, the horned dinosaurs roamed, the ceratopsians, Triceratops, Styracosaurus, Chasmosaurus. Imagine a herd of Triceratops. They were low-slung, heavy animals with 3 horns and a giant frill of bone protecting their necks. They were the bison of the Cretaceous. They grazed on tough palm fronds and cycads. They had beaks like parrots and batteries of shearing teeth. Crunch, crunch, crunch. They were social animals. They moved in herds, communicating with low grunts and rumbles. If threatened, they would form a circle, horns facing outward, a wall of bone, but mostly they slept. They rested in the warm sun, their heavy bodies settling into the mud, the colorful Cretaceous birds hopping on their backs to eat ticks. Section 22, the king in repose. The Cretaceous was drawing to a close, 66 million years ago. The climate had cooled slightly, but it was still warm. The sea levels were dropping, draining the Western Interior Seaway. The coastal plains were widening, and here in the river valleys of Montana lived the tyrant lizard king, Tyrannosaurus rex. Forget the roaring monster of the movies. Let us look at the animal as it likely was. A 7-ton predator. It was not built for marathon running. It was a walker. Its legs were massive pillars of muscle. It moved with a steady, ground-shaking stride. See it sleeping. A T-Rex lying down is a mountain of flesh. It curls its tail around its body. It rests its massive head on its forearms. Its breath is a deep, slow huff that stirs the dust. It was likely covered in fine, downy feathers when it was young and perhaps retained some as an adult. A giant, fuzz-covered beast sleeping in the afternoon heat. It had the strongest bite force of any land animal in history. But it didn't use it constantly. Most of its time was spent patrolling, sniffing the air with a sense of smell that rivaled a bloodhound. It was a patient hunter. It would wait for days for the right opportunity. The world it lived in was lush. Groves of dawn redwoods, fields of ferns, the sound of the wind in the broad-leaved trees, the drone of insects. It felt like the peak of existence. The dinosaurs had ruled for 160 million years. They had survived ice ages, heat waves, rift valleys, and volcanoes. They were the masters of the earth. They seemed eternal. Section 23. The sky fall. But space is patient too. For millions of years, a rock had been drifting in the asteroid belt. A piece of debris, perhaps created by a collision eons ago. It was a carbonaceous chondrite, dark, ancient, about 6 miles wide, the size of Mount Everest. It was nudged by gravity. It entered a new orbit. It crossed the path of the Earth. It happened on a spring day. We know it was spring because the fossilized flowers tell us so. The asteroid approached from the southeast. It came in at a steep angle. It was moving at 40,000 miles per hour. It crossed the atmosphere in 2 seconds. The air in front of it was compressed so hard it turned into plasma. A hole was punched through the sky. It struck the shallow waters off the coast of the Yucatan Peninsula in Mexico. Chicxulub. The impact was silent for a split second, and then the world ended. The energy released was equivalent to 100 million nuclear bombs. A crater 100 miles wide was excavated in moments. The bedrock was melted and thrown into the stratosphere. A wall of water, a mega tsunami, radiated out from the impact site. It was thousands of feet high. It swept across the Gulf of Mexico, scouring the coastline of North America. It rushed up the Mississippi embayment, carrying marine fish and burying them in North Dakota. But the water was not the true killer. The killer was the debris. The melted rock that was thrown into space cooled instantly into tiny glass beads. Tektites, trillions of them. They fell back to Earth like glowing hot rain. As they fell through the atmosphere, the friction heated the air. The sky turned into a broiler. The temperature of the atmosphere spiked to hundreds of degrees. The forests caught fire, a global firestorm. The Triceratops in Montana looked up and saw a second sun growing in the sky. Then the sky turned red. Then the hot glass began to fall. The T-Rex woke from its sleep. It stood up. It looked at the horizon. And then the heat arrived. Section 24, the Great Silence. And then the smoke. The fires burned themselves out. The dust from the impact and the soot from the fires rose into the stratosphere. It circled the globe. It blotted out the sun. Photosynthesis stopped. The plants died. The herbivores starved of food died. The carnivores starved of herbivores died. The Mesozoic era ended in the dark. This was the KPG extinction, the Cretaceous-Paleogene boundary. It is a thin layer of gray clay found all over the world. Below the line, dinosaur bones, ammonites, pollen of tropical plants. Above the line, Nothing. For months, perhaps years, the Earth was shrouded in darkness. The temperature plummeted. The impact winter. The silence was absolute. The roaring of the T-Rex was gone. The lowing of the Triceratops was gone. The humming of the insects was gone. The birds were mostly gone. The oceans were silent too. The plankton had died. The food chain collapsed. The great mosasaurs starved in the dark water. The ammonites, with their beautiful spiral shells, drifted to the bottom one last time and never rose again. But life is tenacious. Deep in the burrows under the roots of the dead trees, something was stirring. Small, furry creatures, mammals. They had been living in the shadows of the dinosaurs for 100 million years. They were nocturnal. They were used to the dark. They were scavengers. They ate insects, roots, decaying matter. They huddled together for warmth. They slept through the worst of the cold. They woke up to a world that was gray, cold, and empty. The only plant that thrived in the aftermath was the fern. Ferns love disaster. Their spores can survive in ruined soil. When the sun finally broke through the clouds years later, the world turned green again. But it was a monochrome green. A fern spike, fields of ferns covering the graves of the giants. The dinosaurs were gone, except for the birds. The stage was empty. The mammals crawled out of their holes. They blinked in the light. They looked at the empty world, and they began to explore. The Cenozoic era, the new life, had begun. Section 25. The Cenozoic morning. The dust of the asteroid settled. The fires burned out. The fern spores that had covered the scarred Earth began to retreat, replaced once again by forests. We enter the Cenozoic era, the new life. It began with the Paleocene epoch, 66 million years ago. The world was quiet. The giants were gone. The T-Rex was a memory buried in the mud. The landscape was open for the taking. The mammals, who had been small, scurrying creatures of the night, began to step into the daylight. They were cautious at first. They were small, shrew-like, rat-like. But with no dinosaurs to eat them, they began to grow. Within a few million years, the forests were filled with strange, primitive beasts. They were the rough drafts of modern animals. Pantalambda, a creature the size of a sheep but with heavy feet and a long tail. It moved slowly through the subtropical undergrowth. But the true rulers of the Paleocene were not mammals. They were birds. Without the dinosaurs, the birds, the only surviving dinosaurs, took back the crown. Meet Gastornis, a giant flightless bird. It stood 7 feet tall. It had a beak like a heavy pair of shears. It walked on powerful, thick legs. Imagine the sound of the Paleocene forest, the heavy thud-thud-thud of a giant bird stalking through the ferns. It was a terror to the small horses and early primates, but to us, looking back, it is a majestic image. A feathered giant patrolling the ruins of the Mesozoic. Section 26. The Eocene hothouse time drifted forward to 56 million years ago. The Eocene epoch. And then, the heat returned. A massive release of carbon into the atmosphere, perhaps from volcanic vents in the North Atlantic, or from melting methane ice on the sea floor, triggered the Paleocene-Eocene thermal maximum, the PETM. The Earth became a hothouse. The average temperature rose by 5 to 8 degrees Celsius. The poles became tropical. If you traveled to the Arctic Circle in the Eocene, you would not find ice. You would not find snow. You would find a swamp. Imagine standing on Ellesmere Island in the high Canadian Arctic. Today, it is a frozen tundra. But in the Eocene, it was a lush forest of dawn redwood and cypress trees. There were alligators swimming in the Arctic Ocean. Giant tortoises, which cannot survive freezing temperatures, lumbered through the warm mud at the North Pole. But the strangest thing about this polar jungle was the light. The temperature was tropical, but the seasons were still polar. In the summer, the sun never set. The plants grew in 24 hours of daylight, a frenzy of photosynthesis. In the winter, the sun never rose. Imagine a tropical jungle in total darkness. For 3 months, the Eocene Arctic was a world of black warmth. The trees dropped their leaves not because of cold, but because of the dark. The alligators slowed down. The animals navigated by sound and smell. It was a dark, warm, wet dream of a world. In this hothouse, the mammals exploded in diversity. The first true primates appeared, the ancestors of monkeys, apes, and us. They were small, lemur-like creatures leaping through the dark canopy. The first bats took to the sky. For the first time, mammals were flying. They filled the niche that the pterosaurs had left empty. Section 27. The return to the water. And in the warm, shallow Tethys Sea, the ocean that separated Africa from Eurasia, a wolf-like animal was looking at the water. This is Pachycetus. It lived on the edge of the estuaries. It was a hairy, four-legged land animal. It had hooves. But its ears were different. The bone structure of its ear was adapted to hear underwater. It was the ancestor of the whale. Over millions of years, the descendants of Pachycetus spent more and more time in the water. Ambulocetus, the walking whale. It looked like a furry crocodile. It had webbed feet and a long snout. It was an ambush predator. It swam awkwardly, paddling with its hind legs. Then came Cucusatus. It looked like an otter. Its legs were smaller. Its tail was stronger. It swam with an undulating motion. And finally, Basilosaurus. This was the king lizard whale. It wasn't a lizard, but when fossils were first found, they thought it was a sea serpent. Basilosaurus was fully aquatic. It was 50 to 60 feet long. It had a long, snake-like body. It had tiny, useless hind legs, vestigial limbs left over from its land-walking ancestors. It lived in the warm Eocene oceans. It didn't dive deep. It cruised the surface waters. It had no sonar. It couldn't echolocate like a modern dolphin. It just listened. The evolution of the whale is one of the most soothing stories in biology. It is a story of returning home. Life came from the sea, conquered the land, and then finding the land too crowded or too harsh, turned around and slipped back into the cool embrace of the ocean. The whales grew large because the water supported their weight. They lost their fur because the water kept them warm, and later blubber would keep them warm. They lost their scent because you cannot smell underwater. They became creatures of sound and touch. By the end of the Eocene, the oceans were full of early whales. Drifting, calling, the song of the whale was beginning to be written. The hothouse could not last. 34 million years ago, the Eocene ended. The Oligocene began. The continents continued their slow dance. South America finally broke its last connection with Antarctica. The Drake Passage opened. This was a pivotal moment in the history of the Earth's climate. As soon as the gap opened, the ocean currents changed. A strong current, the Antarctic Circumpolar Current, began to flow around Antarctica. It circled the continent endlessly, west to east. This current acted like a wall. It blocked the warm tropical water from reaching the South Pole. Antarctica was isolated. The heat was cut off. The continent began to freeze. The forests of Antarctica, the beech trees, the ferns died. The snow fell and did not melt. The glaciers formed. For the first time in hundreds of millions of years, the Earth had an ice cap. The icehouse Earth phase began. The cooling spread across the globe. The sea levels dropped as water was locked up in the ice. The tropical jungles that had covered North America and Europe retreated to the equator. The world became drier. The lush broadleaf forests died back. And in the open spaces that were left behind, a new kind of plant seized the opportunity. Grass. Section 29. The Whispering Ocean. We take grass for granted, it is everywhere. But for 90% of Earth's history, there was no grass. In the Oligocene and the Miocene that followed, the grasses spread. They were tough. They grew from the bottom, not the tip, so if an animal ate the top, the plant didn't die. They could survive fire, they could survive drought, and they contained silica, tiny particles of glass in their leaves. This made them hard to chew. The spread of grasslands changed the sound of the planet. Forests are vertical, they muffle sound. They are places of shadows and echoes. But the grasslands, the steppes, the savannas, the prairies were horizontal. They were the green oceans. Imagine the sound of the wind blowing over a Miocene prairie, a continuous soft shushing sound, the rustle of a billion dry stems rubbing against each other. It was a white noise machine the size of a continent. The rise of the grasslands forced the animals to change. If you live in a forest, you need to be agile. You need to step over roots and duck under branches. If you live in a grassland, you need to be fast. There is nowhere to hide. If a predator comes, you must outrun it. So the legs of the mammals got longer. The horses, which had been small, dog-sized forest dwellers eating leaves, began to change. They grew taller. Their toes fused into a single hoof for running on hard ground. Their teeth became longer and harder to grind down the glassy grass. This was the co-evolution of the grazer and the grass. The herds appeared. Vast numbers of horses, camels, and antelopes moving across the plains. This is the most restful image of the Cenozoic, a vast open plain under a blue sky. The wind rippling the grass like waves on the sea. A herd of horses grazing, heads down, tails flicking. The rhythmic sound of tearing grass and chewing. Rip, chew, rip, chew. Section 30, the giants of the Oligocene. In this transition period, some mammals grew to immense sizes to process the low-quality food. Meet Paraceratherium. It was a rhinoceros, but it had no horn, and it was the size of a house. It stood 16 feet tall at the shoulder. Its head could reach 26 feet into the air. It weighed 20 tons. It was the largest land mammal to ever walk the earth. It looked like a cross between a rhino and a giraffe. It had long, pillar-like legs and a long neck. It wandered the open woodlands of Asia. It was a browser, stripping leaves from the tops of the trees that the cooling climate had left behind. Imagine standing next to a Paraceratherium. You would not even reach its knee. It would move with agonizing slowness, a creature that heavy cannot rush. Every step was a calculation. It had no natural enemies. Nothing could bring it down. It lived a life of total security. It would stand in one spot for hours, slowly demolishing a tree branch, blinking its long eyelashes in the sun. The babies were born the size of a horse. They would walk in the shadow of their mothers, protected by legs like tree trunks. The Oligocene was a time of strange giants. There were the hell pigs, entelodonts, ugly bison-sized scavengers with bony lumps on their faces. There were the hyenodons, predators with jaws that could crush bone. But as the climate cooled further into the Miocene, the giants began to fade. The forests they needed for food were shrinking. The grass was winning. Section 31. The Miocene Optimism. The Miocene epoch began 23 million years ago. The world was beginning to look like the world we know. India had finished its journey. It slammed into Asia. The collision was slow, but the force was unimaginable. The crust crumpled. The Himalayas began to rise. The Tibetan plateau was lifted up. This massive wall of rock changed the weather patterns of the world. It created the Asian monsoon. The seasonal rains that water half the world's population today were born from this slow-motion car crash of continents. In Africa, the apes were evolving. Proconsul, a tailless primate moving through the canopy. But the forests of Africa were breaking up. The drying climate was turning the jungle into a patchwork of wood and savanna. The apes were finding themselves on the ground more often. They had to cross the open spaces to get from one patch of trees to another. They began to stand up. It was an experimental posture. Standing on two legs allowed them to see over the tall grass. It kept them cooler in the hot sun. It freed their hands to carry things. It was the beginning of a long walk. But let us not rush to humans. The Miocene was the age of apes. There were dozens of species of apes. They lived in Europe, in Asia, in Africa. It was a planet of primates. The kelp forests appeared in the oceans, cold water algae that grew hundreds of feet tall. A new ecosystem. The sea otters evolved to live in them, wrapping themselves in kelp to sleep so they wouldn't drift away. The biggest shark of all time, Megalodon, patrolled the warm coastal waters. 50 feet of cartilage and teeth. It hunted the small whales that were abundant in the Miocene seas. It was a vibrant golden time, the high Miocene, a peak of diversity before the final cool-down. Section 32, the Pliocene Bridge and the Cooling Stream. We drift out of the Miocene and into the Pliocene epoch 5 million years ago. The world was getting colder. The golden age of the apes was fading as the forests shrank further. But the most significant event of the Pliocene happened in silence, underwater. For millions of years, North America and South America had been separated by a deep ocean channel. The Pacific and the Atlantic Oceans mingled their waters freely, but the tectonic plates were moving. The Pacific plate was sliding beneath the Caribbean plate. Slowly, volcanoes rose from the sea. Islands formed. The sediment from the rivers filled the gaps. About 3 million years ago, the gap closed. The Isthmus of Panama was formed. It was a bridge of land. For the first time, the animals could walk from north to south. This was the Great American Biotic Interchange. Imagine the slow traffic on this bridge. From the north, the cats, the bears, and the horses walked south. From the south, the strange giants walked north. The glyptodonts, armadillos the size of Volkswagen Beetles, the giant ground sloths. Let us watch a megatherium, a giant ground sloth. It was 20 feet long, it weighed 4 tons, it walked on the sides of its feet because its claws were so large it couldn't put them flat on the ground. It was a creature of immense leisure. It moved in slow motion. It would hook a branch with its massive claw and slowly pull it down to its mouth. It had no predators that could threaten an adult. It was a mountain of shaggy hair and indifference. But the closing of the isthmus had a global consequence. It blocked the ocean current. The warm water from the Atlantic could no longer flow into the Pacific. Instead, it was forced north. This created the Gulf Stream. It pumped warm, moist air up toward the Arctic. When that moisture met the cold polar air, it fell. Not as rain, but as snow. The snow fell and did not melt. It piled up. It compressed. It turned to ice. The northern hemisphere began to freeze. The Pliocene ended in a chill. The curtain was rising on the Pleistocene. Section 33. The pulse of the ice ages. The Pleistocene, 2.5 million years ago to 11,700 years ago. This is the time of the great ice ages, but it was not one single block of cold. It was a pulse, a slow rhythmic heartbeat of the climate. Glacial, interglacial, glacial, interglacial. Every 40,000 or 100,000 years, influenced by the subtle wobbles of the Earth's orbit, the Milankovitch cycles, the ice would grow, and then it would retreat. Let us settle into the deepest part of a glacial maximum. The ice sheets descended from the north. The Laurentide ice sheet covered Canada and the northern United States. The Fennoscandian ice sheet covered northern Europe. These were not patches of snow. These were cliffs of blue ice 2 miles high. Imagine the weight. The ice was so heavy that it physically crushed the Earth's crust. It pushed the continent down into the mantle. The land bowed under the pressure. Today, thousands of years after the ice has gone, the land in Scandinavia and Canada is still rebounding. It is rising back up, millimeter by millimeter, like a slow-motion mattress recovering after a heavy sleeper has stood up. The sound of the Ice Age was a deep, grinding bass. The glaciers were moving rivers of solid rock. They scoured the landscape. They carved the U-shaped valleys. They gouged out the basins of the Great Lakes. They polished the granite bedrock until it was smooth. The world was quieter. Snow is a sound dampener. It absorbs acoustic energy. A world covered in snow is a hushed world. The sharp noises of the landscape are muffled. The sea levels dropped. The water was locked in the ice. The coastlines extended out for miles. You could walk from England to France on dry land, Doggerland, a vast low tundra plain where the North Sea is today. Section 34. The Woolly Pilgrims. On the edges of the ice in the dry, cold Mammoth Steppe lived the megafauna. The woolly mammoth, Mammuthus primigenius. Close your eyes and picture the animal. It is an icon of patience. It was covered in a double coat, a thick woolly undercoat to trap heat, and long, shaggy guard hairs hanging down to its knees. Its ears were small to prevent frostbite. Its tail was a short flap of skin. It was built for the cold. A herd of mammoths walking through a blizzard is a study in endurance. They walked in a single file, the large females breaking the trail through the snow. They moved with a slow, rocking gait, left, right, left, right. Their curved tusks were used as snow plows. They would sweep the tusks side to side, clearing the snow to reveal the dry grass underneath. They were social animals. They touched each other with their trunks. They rumbled in low frequencies, sounds that traveled for miles through the cold, dense air. Walking with them were the woolly rhinoceros, heavy, hump-backed creatures with two flat horns. They were solitary, grumpy, and nearsighted. They grazed in the wind-swept valleys. There were the saber-toothed cats, Smilodon. They were not fast runners. They were ambush predators. They relied on their immense upper body strength to wrestle prey to the ground. They were stocky, muscular, and heavy. And in the caves, the cave bears slept. They spent the long winters in deep hibernation, their heart rates slowing to a crawl, a sleep that lasted for months. Section 35. The Firekeepers. And there was another animal on the steppe, a primate that had learned to leave the trees, learned to walk upright, and learned to carry fire, the genus Homo, humans. In the context of the Earth's history, our arrival is sudden. But let us view it in slow motion. We were walkers. That is our great adaptation. We are not fast, but we are efficient. We can walk for days. We tracked the herds. We followed the seasons. We were the fire keepers. Think of the campfire. It is the television of the Pleistocene. For hundreds of thousands of years, humans sat in the dark, watching the flames, the orange light flickering on the cave walls, the warmth radiating against the skin. The fire kept the predators away. It cooked the food. But mostly it was a focal point for stillness. To sit by a fire is to be mesmerized. It was the first act of collective meditation. We lived in rhythm with the ice. When the glaciers advanced, we retreated south. When the ice melted, we followed the herds north. We were a part of the ecosystem, just another predator on the plain, wrapped in furs, watching the horizon. Section 36. The Holocene Stability. 11,700 years ago. The last great ice age ended. The wobble of the earth shifted. The summer sun became stronger. The great melt began. Water poured off the ice sheets. Giant glacial lakes burst their dams, carving canyons in days. The sea levels rose 400 feet. Doggerland was flooded. The bridge between Alaska and Siberia was submerged. The climate stabilized. We entered the Holocene epoch, the entirely new. It is a period of unusual stability. For 10,000 years, the temperature has remained remarkably flat. A long, warm summer. The megafauna couldn't adapt. The climate changed too fast and the humans were too efficient at hunting. The mammoths faded away. The last one survived on Wrangel Island until the time the pyramids were being built in Egypt. A lonely, shrinking herd on an island in the Arctic Ocean. With the stability came agriculture. We stopped walking. We planted seeds. We waited. Agriculture is a slow process. It requires patience, watching the wheat grow, waiting for the rain. We built houses, we built walls, we built cities. But underneath the concrete and the noise of the modern world, the earth is still the same. The tectonic plates are still moving 1 inch per year. The mantle is still churning. The core is still cooling. Section 37, the deep future. We have reached the present moment. You are lying here, a product of 4.5 billion years of drifting, cooling, heating, and evolving. But the story does not end here. Let us take one final look forward. Into the deep time of the future, the continents will continue to drift. The Atlantic Ocean will widen, then perhaps close again. In 250 million years, the continents will merge once more. Pangaea Ultima, a new supercontinent, a new vast red desert in the interior. New mountains will rise, and old mountains will be worn down to sand. The sun will slowly get brighter. In 1 billion years, it will be too hot for liquid water. The oceans will evaporate. The earth will return to a steam-filled greenhouse, much like it was in the beginning. But that is a long, long way off. For now, the earth is hospitable. It is blue. It is green. It is the perfect temperature for water to be liquid, for life to breathe, for you to sleep. Conclusion. The resting planet. We have traveled from the violent fire of the Hadean to the frozen silence of the Cryogenian. We have seen the orange skies of the Archean and the blue skies of the Jurassic. We have watched mountains rise and fall like the heaving of a chest. We have seen that the earth is resilient. It has frozen over and melted. It has been choked with carbon and scrubbed clean with oxygen. It has been hit by rocks from space and torn apart by its own internal heat. And through it all, it spins. One rotation every 24 hours, traveling around the sun at 67,000 miles per hour, but you cannot feel the motion. You are held safely by gravity against the surface. The history of the Earth is a bedtime story. It is a story of things settling down, dust settling into rock, magma settling into crust, carbon settling into coal. Everything seeks its level. Everything seeks its rest. As you drift off to sleep, remember that you are part of this slow, heavy procession. The atoms in your body were forged in stars, gathered in the nebula, cycled through the rocks, the water, the air, the dinosaurs, the ice, and now they are you. You are the Earth, observing itself. And now, the Earth needs to rest. Good night.